Okay, so we're gonna continue the stuff from before. So right now we're gonna go into okay, right. Let me just review. So we have some we have found out there's this thing called a steady state. Oh, also turns out that steady state is basically just a fancy word for an equilibrium, which I'll go into a bit more detail later on when it comes up. So first of all, at the steady state, um, the the new and the old k, the baby k's, are the same, and that is equal to baby k star, because it looks like this, k, and then like this, and it's like the same. So this is k star. Cool, cool, cool. And so the thing here, all right. So in the formula that we had with like the whole um like k apostrophe, like future k equals all these old k's and then old k's, we can just replace all those like different types of k's with k star. So we can just do like this. The original formula, I don't want to scroll too much because like my laptop might freeze, but okay, it's really far up. Okay, this thing right here. We're just gonna replace all these like k's here with k star. So once we have replaced those, we just rearrange this. Okay, like multiply it all by 1 times 1 plus n to get rid of these to here. And then, why is my thing lagging? And then after that, we would, all right, we're gonna move this term over here to the other side and expand the brackets out, get rid of these extra k's, blah, 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 rearrange, and we get k star n plus d equals szfkn. This part over here, the zfk, is income, right? Like this is equal to y. And this little s is a savings rate. So this whole thing, oh, did I say something before? Oh, never mind, okay. So this whole thing is just S times Y, which is savings, which is a pretty cool thing to know or whatever. Cool. So basically they're saying that this term, this like K n plus D, whatever this is, like this term is equal to the savings at, the steady state point. So this is basically what the yeah, I'll calm down in a few minutes. So this is what the graphs would look like. K star n plus d is a straight line because it's all, wait, did I already do this before? Oh, I think I did, whatever. This is a straight line because it's just all constants. Oh, wait, I didn't. I don't know. I don't think I did. What the hell? I don't know what I did before. Whatever. Anyway, okay, I'll just go over it again. So K star times n plus d, this is a straight line because all these values are all constant. Like K star is constant, it's like given. N is a population growth rate. That's, like a growth rate. It's not going to change. D's depreciation is not changing. It's all constant. So it's just like a number. So, wait. Right. So it's just like a straight line. Why would it be like this? Oh, right. Oh, I'm so dumb. It's because N plus D is basically like the slope of this line, where the, this is sort of like the X kind of, like, it's like the X is K star. So there's like a K star here times N plus D. So like the N plus D is basically like the slope of this line. So whatever this n plus d is, that's what the slope of this line is. Anyway, so there's that. And we're just going to assume that this curvy line is a SZFK and that whole like savings thing. That's cool, whatever. Next, that's just like, I don't know, something, I guess, whatever. So first we're going to look at, different types of changes. So the first one that we're going to look at is increase in savings. And then I think we'll go into an increase in N and then an increase in Z. So to start off with an increase in savings, first of all, we have to wait for my laptop. Okay, so first we have this line over here, and then our S increases, so like this little multiplier factor, whatever, increases. So it's just like, a bit more stretchy, a bit more higher, kind of. It just like stretch out this line. So it goes upwards, and that's our new this savings curve, I guess. So this gives us a new steady state since it intersects this straight line at a different point. So the K star increases, and since K star increases, the Y increases and all that stuff. So now one thing is that there are no growth effects because of this, because like there's nothing changing like inherently with like the stuff. It's only that the savings is, you know, increasing. You're just like saving a bit more. You're not like growing or whatever, you know? So basically what it means is that the growth rate of the baby K and the growth rate of the Y, the baby Y, are both still 0. These are the per capita values of capital and income. And the growth rate of the big K and the growth rate of the big Y is 0. Wait, why is it 0? Shouldn't it be N? I think this should be N. I think I made a mistake. Okay, yeah, I think it should be N. I guess I'll mention that in the video. Let's see what else. Okay, right. So another thing is that because of this new, this new line, basically, okay, so K star is the steady state. Steady state is basically an equilibrium for things that are constantly changing. So you know how you might have like a line,
Flies.
oh, we have, wow, cool. There we have the man of a butt. Oh wait, whatever. This thing over here is an equilibrium. It's a point at which it's like beautiful and perfect and yay, whatever, right? But thing is, how are we supposed to create an equilibrium for things that are constantly changing? For example, total income. Income is always increasing, you know? Income is increasing, capital is increasing because, you know, we're constantly making more machines. And income is increasing because we're constantly producing more things, you know, because, like, more people are born, so, like, we need to make more stuff for them and, like, all that stuff. So basically, for these things, we can't have this, like, little stationary equilibrium, which is why we have sort of like a little path, like a steady state path, that is basically their equilibrium. So, like, this is the equilibrium for them, and basically, if you were to increase if the equilibrium were to increase, it would essentially mean like increasing that steady state path, like you'd like move on to like the next level kind of thing. So, where am I going with this? Right. So basically, steady state, or like this little chart thingy, is to show like the equilibrium for growing variables, so like Y and K. So it's called steady state growth path. And if something, and not if something, if our current economy is on the growth path, like, you know, if like our values are matching up and everything, then it'll stay on it. If it's not on that growth path, like if it's somewhere over here, I guess, it'll like sort of like merge to like join that steady state path, because that's just how it works. And in the Solow model, what is this, K and Y? So the income and the capital, they all grow at a steady rate, like the steady state. And as a result, the ratios between the variables are constant. And this is kind of why in the beginning when we did like the, what is it? That like growth rate thingy, like this stuff, all the big Y's had a growth rate of, like all the big ones had a growth rate of like N. What's another one? K equals N. Is K one of things? Whereas like all like the baby ones, like little y or like this little k, it was all 0 because basically the ratios between these two things are staying the same. So the growth rates between like y over n, for example, is 0. But like the big things do change. Anyway, that's just like a side note. So that's something to keep in mind. So now we'll go on to the golden rule, capital accumulation. So basically, this is basically like, I think this is basically just saying like what's the maximum amount of consumption a person can get in this model. Okay, so first of all, let's just write out the consumption formula. So it's C equals 1 minus S times Y. So we can replace this Y with the formula here. We can expand this into 2 parts. We know that SZFK, this thingy, equals n plus dk at a steady state. We know this from that formula, like the very first thing that we did, where you had to like equate them all, and we were like, oh wow, look at this thing. Remember? We had to like rearrange stuff and like we had to equate this. So this is that. So it's basically just the SZFK thing is equal to this at the steady state. Cool? So basically, since we're like basically only working with steady state, we can just replace it. So now we have this whole formula is equal to consumption. Okay? So now when we plot out this stuff, we get oh, this makes sense actually. Okay. So first we have our ZFK thing, and then we have that whole thing multiplied by S. So S is like 0.1, the savings rate. So as a result, like this SZFK thing would be like smaller than it. Cool? And then we also have our normal straight line going upwards. So now at the steady state is where as where this straight line is equal to the SZFK line. So the point over here. So this point over here, the SZFK, so this is the Y, this is the baby S, so this is equivalent to the total savings. So from this point to this point, this is savings. I actually don't even know if this is true, but yeah, I mean it should be, whatever. So this is savings, and ZFK, so at this point this is N plus DK, and then we have ZFK over here. So basically they're saying that this distance between these two things is a consumption. So it's like this minus this, and that is the distance. So here is consumption, here is savings, and then this whole thing equals Y, because you know, like this ZFK is Y, and that brings you back to Y equals C plus S. With your money that you earn, you can either consume or you can save. So sort of like a it's like a nice visual representation, I guess, with like a whole bunch of letters. Anyway, so there's that. Steady state, right, cool, blah, blah. All right, and remember, okay, so the thing is, this is a savings, and this is like also kind of the savings, like, they're all the savings, oh, never mind, forget that. Anyway, just remember that, like, this thing is the output per worker line. These two are sort of like the savings thing, like, basically, like, when these two merge is where the savings is, the savings point is, so it's just, you know, so it's like output minus savings equals our consumption. Cool. So now we want to look at where is this consumption at the maximum. And this is actually where the slope of the ZFK line, so the ZFK line, which is the higher, which is like the top, oh my god, why is this like this? Which is the taller curvy line, has the same slope as N plus D, as that straight line. So it's like over here, so we have like our ZFK line, so our production output per worker. We have our SZFK line, which is like this multiplied by S. And we have our straight line, N plus D. So it's like this is our output, this is our savings, this is sort of our savings too. So basically, we want this line over here to have the slope of N plus D. And so if we just look at that, it's at this point, and so like this is like the max, whatever. Anyway, if you just even look at the graph, comparing like the distance between the curvy line and the straight line at like different points, see the maximum comes at like this point over here. So like that's just how you figure it out. And you might be like, why are we looking at the distance between this line and this straight line and not this line and this smaller curvy line, right? Because then like it makes sense, right? But the thing is basically, I'm sorry, hold on, what is it again? It has to be basically the things you can't, you would have to change the entire, hold on, we have a straight line, we have a curly line, we have another curly line, I mean curvy. So we have curvy 1, curvy 2. Thing is, we know that it always is at a point where the C2 always meets the straight line, right? So it has to be like this or this. Like it can never be over here because it has to meet that straight line. So the thing is, we sort of know that it So we compare to this. Oh, it's like the worst explanation ever. Anyway, whatever. So just see, you just always have to compare to the straight line because it's always gonna have to intersect that and blah blah blah. Okay, so the next experiment is an increase in n. Oh my, this is so long. Increase in n. So if the n increases, then the thing that increases is the straight line because it's like n plus d times k. So it's just like the slope increases, so it's like it goes upwards. So we meet at a lower k2, so this thing falls. And so the y equals z of kn falls. I mean z of k. Cool. If there's an increase, oh wait, hold on. Actually, I have to think about this. An increase in n is an increase in the population growth rate. If the population is growing like a lot, if there are like so many people, whatever, that means that the amount of income that goes to each person falls, you know, because you have like more mouths to feed or whatever. So because of that, this like y, which is like the baby y, which is like the y per person, falls. Next, increase in z. So an increase in Z is an increase in the technology or like the productivity of the workers. And if there's an increase in that, we sort of know that, you know, like if people are more productive, then Y has to increase. So like without even doing like all the graphs and everything, we know that. But we can also do the graphs, whatever. The Z1 goes to Z2, it's sort of like a multiplier. So this chart sort of just like lengthens, so it goes up, and the K increases. Cool. So last topic before I ended this off is convergence. So convergence, okay, so convergence is like a pretty cool topic. Basically, it says that no matter, okay, so convergence has to do with like economic growth. And basically, it's that no matter what condition two different countries are in the initial stages, as long as they have the same type of technology, if they have the same technology, they will converge to the same steady state path. So steady state path, as you know, is the equilibrium, like the equilibrium of like everything, which kind of like sounds off because they're saying like if like, you know, one country has like, I don't know, like 1% or like, I don't know, like one worker, okay, that doesn't really make sense. Whatever, one machine. Another country has like, you know, 1,000 machines, and they have like the same like growing technology, they have the same growing population, they have like the same, basically the same growth rates. Oh wait, no, not the same growth rates. If they have the same like population growth rates and like technology growth rates and like same technology and stuff like that, they're gonna end up like meeting at some point. You might be like, oh, but like wouldn't they make more sense if they were both like, you know, they stay together? I mean, like they stay like far away. And like, yeah, some people think that too, and they think that this model is dumb. And there's like another model that says like, you know, if you start at a lower point, if they have the same technology and like have the same everything else, then they're gonna stay far away. Like this, pretend this is like money per person, I guess. And this is time. So anyway, yeah. So it's just like conversion, basically like they're all converging together to the same SS path. And here's like a small little diagram where like the poor people, they start off so low and they converge to this SS path. And the rich people, they start off actually even like above the SS path, but they converge to it, which is so odd. But the thing is, the two conditions that they need for this to be true is diminishing returns to scale, which is the fact that if I multiply my inputs by some number, then my output will increase by a lower amount. And it also has to have the same technology, which is which is like the whole title thing. So anyway, the diminishing returns to scale. So that part is like, you know, like you can't just keep increasing your capital and your labor over and over and over again. You know, like at some point you have to become like, you know, somewhat less productive or whatever, right? So that might be like a reason for why this is true and all that. But yeah. So now, the thing with this convergence, so this is called absolute convergence or unconditional convergence, because it's sort of like, it's kind of like dumb, you know? Because the thing is, in real life, countries have different levels of technology, right? So technology is gonna mean the letter Z, so they have like different letter Z's. And if they have different technology, the thing we'll be using is conditional conversions. Like the word, like it's conversion, but there's like two types: unconditional or absolute, and conditional, which is the one with different technology. And this is basically saying that no matter what you do, if there's different technology, then they will not be able to catch up. Like they will not meet at the same steady state. I don't really know what this is like supposed to like mean, I guess. Like thing is, anyway, whatever. Okay, that's it. Bye.